14 minutes. That's how long I had before the atmospheric processor on Deck 7 finished killing me. Let me back up. My name is Dr. Priya Okafor, and I am a systems engineer aboard the galactic cooperative vessel, Resonance of Accord. I'm the only human on it. I was posted here 6 weeks ago as part of the exchange program Humanity's grand diplomatic gesture. The idea being that if you stick one of us in a ship full of Velhari for long enough, everybody learns something useful. The Velhari are the ones who look like someone crossed a mantis with a very judgmental librarian. 4 arms, compound eyes, a carapace, the color of old jade. They communicate partly through subsonic vibrations in their thorax. I communicate through a translation collar that turns my words into clicks, which the Velhari find either charming or deeply unnerving. 50-50 odds, honestly. I'd been doing great. Adapting, documenting, even making something resembling friends with the ship's primary engineer, a Velhari named Savrak, who tolerated my questions with the infinite patience of someone who has decided that confusion is temporary and curiosity is, at minimum, not dangerous. Then a micrometeorite the size of a grape punched through an auxiliary conduit junction at 0340 ship time, and my great diplomatic adventure turned into a survival math problem. Here's the situation as I inventoried it from the floor of Engineering Bay 3, where I'd been thrown by the depressurization shockwave. Deck 7 atmospheric processor, offline. Primary coolant loop, severed. Regenerative chemical scrubber running on residual power, estimated 14 minutes before cascade shutdown. Ship air recycling, 73% functional. Cross-deck pressure, differential. Growing. My suit, emergency rated. Not rated for a full scrubber failure at this pressure. Time until I personally stop breathing comfortably, approximately 22 minutes. So, the math said I had 14 minutes to fix a scrubber system I had never worked on before, using tools designed for Velhari hands, which have 4 fingers and a prehensile secondary claw that I definitely don't have, while the ship's automated systems politely suggested I evacuate to a safe zone, approximately 4 decks away. I told the automated systems to mind their business and started taking the scrubber housing apart. The Velhari engineering philosophy, and I'd read the cultural briefing 3 times before posting. Because I'm that kind of nerd is built around something they call corrective sequencing. You identify the failure, you identify the correct replacement procedure, you execute the procedure in order. No improvisation. Improvisation is considered an admission that your initial planning was insufficient, which is apparently a significant social embarrassment for them. The Velhari have a word for an engineer who improvises under pressure, excess cater. It translates, loosely, as one who panics elegantly. I was about to do a lot of elegant panicking. Savrak found me 40 seconds after the alarm, moving through the compartment with that liquid grace Velhari have. When they're alarmed, all 4 limbs finding purchase simultaneously on every surface. The subsonic hum coming off their thorax registered in my sternum even through the noise. Human Okafor, they said through my collar translator. The evacuation protocol requires your immediate departure from S-teens. Cooling loops severed here. I pointed to the jagged tear in the conduit without looking up. The scrubber's running on its buffer. If it shuts down before we patch this, the cross-deck differential's going to hit threshold, and we lose pressure integrity on 3 compartments. I'm going to bridge the loop with the secondary thermal line. There was a pause. The subsonic hum shifted frequency. I'd learned enough to recognize that as the Velhari equivalent of someone blinking very slowly in confusion. The secondary thermal line, Savrak said, is rated for coolant at 43% of the current loop pressure. I know. It will fail. It'll fail in about 9 minutes, I said, which buys us enough time to get the emergency patch from storage locker C7 and install it on the primary. The secondary line doesn't have to work perfectly. It just has to work for 9 minutes. Another pause. Longer this time. I'd already pulled the secondary thermal coupling and was lining it up with the severed primary conduit using a Velhari multi-tool that I was operating approximately 30% correctly, based on my training. The other 70% I was figuring out by logic and the ancient human engineering tradition of trying things until they stop making noise. "This is not the correct procedure," Savrak said. "Correct procedures take 17 minutes, I said. "We have 14. You want to get that patch from C7, or should I?" Another shift in the subsonic hum. I felt it in my back teeth. Then Savrak moved all 4 limbs at once, efficient and fast, towards storage locker C7. I connected the secondary thermal line to the breach. It held. Immediately, pressure readings in the scrubber system stopped their downward spiral. Not fixed, absolutely not fixed. The coupling was vibrating in a way that suggested it had opinions about its current job but stabilized. 11 minutes of life expectancy. Bought 9 minutes of work time. The math was still bad, but it was a different kind of bad. And different kinds of bad are what you work with. I started working with it. The secondary thermal line held for 6 minutes and 40 seconds, which was actually pretty good, given that it was rated for 43% of its current load. I had predicted 9 minutes based on the material specs, which means my model was off by about 26%, which means I'd been optimistic about Velhari metallurgical properties, which is something I was going to note in my engineering log if I survived long enough to have one. When it failed, it didn't catastrophically fail. It wept. A slow, pressurized seep from the coupling joint, spreading across the conduit housing, in a spreading, darkened stain of expelled coolant. The scrubber buffer dropped 15% in 40 seconds. The vibration I'd been listening to shifted pitch by about a half a step sharp, which meant the pressure differential across the coupling was increasing, which meant the line was failing inward, which meant I had maybe 90 seconds before it went from weeping to fountaining, and we were back to the original problem but with added coolant spray. I had the patch kit from C7 open in front of me. Savrak had retrieved it in record time. A Velhari moving at full speed is something to see, like watching a very purposeful 4-limbed spider, and I'd been working through the installation procedure with one eye on the coupling the whole time. Here's where things got complicated. The Velhari patch system is, and I say this with full respect for their engineering culture, exquisite. It's a 4-stage bonding process with a chemical initiator that reacts with the conduit material at a molecular level, creating a permanent repair that is arguably stronger than the original. It requires precise application in sequence. It cannot be rushed. Stage 1 takes 3 minutes. Stage 2 takes 4. Stages 3 and 4 can be parallelized if you have 2 engineers and 4 hands each, cutting total time to about 5 minutes. I had approximately 90 seconds and 2 human hands. Patch procedure time: 7 minutes minimum, 5 minutes optimized with 2 Velhari engineers. Time available: 90 seconds. Gap between what I need and what physics allows: approximately 4 minutes and 30 seconds. There is no mechanism by which the patch can be applied in 90 seconds, Savrak said. They were not being defeatist. They were being accurate. I appreciated the precision. What does stage 1 do, exactly? The initiator prepares the bonding surface by, does it need to cure for 3 minutes? Or does the cure time account for the chemical being applied at standard ambient temperature? The subsonic hum went very still. That one I hadn't heard before. The procedure, Savrak said carefully, specifies 3 minutes. Right, but the procedure was written for your engineering bays. I was already pulling the initiator canister. What's the thermal expansion rate of the conduit material at elevated temperatures? Because right now, that coupling is running hot, way hotter than standard ambient. Hot surface? Same chemical reaction? Faster cure. Silence. Then a rapid series of clicks from Savrak that my collar struggled with. They were calculating, running through material specifications at a speed that made me feel briefly inadequate about my own brain. At current surface temperature, they said slowly, The cure time would be reduced to approximately 74 seconds. Beautiful. I applied the initiator. Stage 2. Stage 2 requires the surface to be below. I know. It'll crack if it's too hot. We apply it to the adjacent section while Stage 1 cures on the breach. Different thermal profile there. I'm touching that section right now and it's running maybe 15 degrees cooler. Cure time comes back up. Call it 2 minutes. The subsonic hum resumed, but it was different now. Faster. Less like confusion, and more like I didn't have a word for it yet. I'd been trying to learn the Velhari emotional register from the briefing materials, but some things you have to hear in person. We worked. I told Savrak what to apply and where, and they executed with four-limbed precision that made my two-handed improvisation look like it was being performed by someone wearing oven mitts. The secondary coupling wept steadily. The scrubber buffer kept dropping. I tracked it in my peripheral vision like a timer I couldn't afford to look at directly. Stage 1 cured in 68 seconds. I'd been 6 seconds optimistic, which was much better than the 26% I'd been off before. I was calibrating. Stage 2 went on in parallel. Savrak applying it with a precision that honestly made me a little emotional. The chemical bonding began. The breach in the primary coolant loop started slowly, then faster sealing. The secondary coupling finally gave out completely at the 1:40 mark. Coolant sprayed across the lower half of Engineering Bay 3 and also across me. It was not pleasant. It was about 4 degrees Celsius, and it smelled like ozone and regret. But it had lasted long enough. The primary patch held. The scrubber buffer steadied at 31% low, but functional. Atmospheric pressure in Deck 7 stabilized. My suit sensors ticked upward from the red zone into the merely alarming yellow zone. I sat down on the Engineering Bay floor, which was now partially flooded with coolant, and did a quick inventory of my condition. Soaking wet, mildly hypothermic in both hands, heart rate elevated, and grinning like an idiot. The procedure you applied, Savrak said, from above me. They were standing on the wall, which Velhari can do, and looking down at me, with all 4 limbs braced in what I'd come to recognize as the Velhari version of profound bewilderment. It was not the correct procedure. It was a correct procedure, I said, just not the one in the manual. You modified a chemical process designed for controlled conditions. I used the conditions I had instead of the conditions I wanted. That's just engineering. The hum from Savrak's thorax was doing something I hadn't cataloged yet. I filed it under Unknown Investigate later and started wringing coolant out of my sleeve. Then the scrubber diagnostics finished running and I looked at the readout. The patch had worked. The primary coolant loop was sealed. The scrubber was recovering. But the micrometeorite hadn't just hit the conduit junction. It had also grazed the edge of the secondary power relay on its way through. And I'd been so focused on the atmospheric crisis that I hadn't checked the relay status. And now, I was checking it, and the relay was reading a partial short across 3 of its 7 circuits. And those 3 circuits happened to be the ones that fed power to the collision avoidance array. And we were currently traversing a debris field. I inventoried my resources. Multi-tool, 60% figured out. Patch kit, mostly used. Approximately 1 liter of spilled coolant on the floor. A Velhari engineer who was beginning to understand that when I said this is engineering, I meant something different than what they were taught. New problem. New math. The math was still bad. I picked up the multi-tool and got back to work. So, collision, avoidance. 3 of 7 power circuits, shorted. Running on 4 of 7. Let me tell you what that means in practical terms for a ship navigating a debris field. The resonance of a chord's collision avoidance array works by pinging ahead with a broad-spectrum sensor sweep and feeding the returns into a predictive model that calculates intercept trajectories. That model needs to process roughly 8,000 data points per second to maintain accurate avoidance at our current speed. With 7 circuits, it can handle 12,000 comfortable margin. With 4 circuits, it tops out at 6,200. Processing capacity at 4 circuits. 6,200 points. Second. Required for debris field navigation at current velocity. 8,000 points. Second. Deficit. 1,800 points. Second. Translation. The system will miss approximately 22% of incoming debris trajectories. Percentage of debris. Objects that are large enough to be catastrophic. About 3%. Probability of a catastrophic miss in the next 4 hours. Uncomfortable. I explained this to Savrak while I pulled open the relay housing. Velhari relay housings, I should mention, are masterpieces of compact engineering. Every component nested inside every other component in a way that makes sense once you understand the design language and is absolutely baffling until you do. I did not understand the design language. I was operating on spatial intuition and a process I've always privately called aggressive archaeology, which means carefully taking things apart and remembering exactly where they came from. The correct procedure, Savrak said, watching me, would require a replacement circuit board from engineering supply. I can retrieve it. How long does installation take? 6 hours. How long until we clear the debris field? At current velocity, 3 hours and 40 minutes. So we need a different solution for the next 4 hours, and then we can do the proper repair. I had the relay housing open now and was looking at the 3 shorted circuits. The short was in the junction layer, a fused connector, where the surge from the micrometeorite's impact had welded 2 contact points together that were not supposed to be touching. Classic overvoltage event. The kind of thing that happens when a grape-sized rock, traveling at several kilometers per second, deposits a tiny amount of energy into your electrical infrastructure. The shorted contacts couldn't be separated without the right equipment. But here's what I noticed. The 7 circuits weren't all doing the same job. 4 handled the sensor processing. 2 handled the display and alert systems less critical right now. We could navigate without pretty graphics. 1 handled the automatic course correction actuators. The automatic actuators were on a shorted circuit, meaning the system could see the debris, could calculate the trajectories, but couldn't automatically steer around them. The avoidance had to be done manually, which meant someone had to sit at navigation and manually fly the ship through a debris field for 4 hours, using data from a sensor array running at 78% capacity. I looked at Savrak. Savrak's compound eyes regarded me with the kind of expressionless attention that I had initially found unsettling and had since come to realize was the Velhari version of very careful listening. Manual navigation through a debris field, they said, at this vessel's size and speed, requires a Velhari navigator's reaction profile. Our neurological response time is faster than mine, I know. Human reaction time is around 200 milliseconds for a simple stimulus. Velhari reaction time, according to the xenobiology briefing, is closer to 80. In debris field navigation, that matters. But you've got 4 limbs, which means you can handle 4 manual inputs simultaneously. I've got 2. Correct. Which is why I should navigate, and you should. Which is why we're going to build a workaround. I was already pulling the spilled coolant with me. Not randomly. I had a thought. The coolant was a thermal fluid, chemically inert, with a specific conductivity profile I'd seen in the material data sheet 3 days ago when I was cataloging the ship's systems because I'm exactly the kind of person who reads material data sheets for fun on my days. Off. What's the conductivity rating on your alert circuit boards? Another long pause. The subsonic hum had a new quality to it today, something I was starting to think of as the frequency of being genuinely unsure what was happening, but committed to finding out. 0.4 Siemens per centimeter at standard temperature, Savrak said. Your coolant is 0.62 at 20 degrees. I was already moving. If I bridge the actuator circuit to the alert display circuit non-essential right now, like I said, the coolant in the junction layer will act as a resistive bridge. It won't carry full current. But it doesn't need to. It just needs to carry enough to allow the actuator microsignals through at reduced bandwidth. The actuators would operate at reduced response speed. Slower automatic correction, yes. But the sensor array stays at full allocated power. We get our 8,000 data points. The system can see everything it needs to see. I calculated quickly. Reduce automatic response speed to about 60% of rated. Which means any debris intercept needs to be flagged 3 seconds earlier than normal. The sensor sweep looks ahead far enough that 3 seconds is fine in 94% of debris field scenarios. Remaining scenarios, 6%. Most of those, debris clusters with complex occlusion. The system can't see through one rock to find the next one. In those cases, slower actuator response is a problem. Probability of encountering a cluster scenario in a 4-hour transit, roughly 1, maybe 2. In those scenarios, manual override would be needed. Manual override by a Velhari navigator with 80 milliseconds reaction time. Very manageable. Manual override by me, more exciting than I would prefer. I looked at Savrak. You navigate. I'll run manual override on the secondary terminal if we hit a cluster. 2-person operation. The subsonic hum rose to a frequency that my sternum processed as something between surprise and decision. You are proposing to use spilled coolant as an electrical component. I'm proposing to use the materials available to solve the problem at hand. The coolant is here. The junction is here. The physics works. We can argue about whether this is elegant later. I applied the coolant bridge to the junction layer using a calibrated drop from a section of conduit tubing as a makeshift precision applicator. Not elegant. Definitely not the correct procedure. The junction hissed faintly as the fluid bridged the gap. The relay readout flickered, then stabilized. The collision avoidance diagnostic cycled. Processing capacity, 8,400 data points per second. Above required threshold. Above it by 400. Actually, because the alert display system had been slightly over-spec'd at installation common practice in Velhari engineering, building intolerance, and today that tolerance was the margin that made my improvised bridge viable. I sat back and looked at the readout for a moment. Then I looked at my hands, which were now coated in a thin film of Velhari thermal coolant, which was going to be interesting to wash off. It works, Savrak said. Not a question. It works, I confirmed. For about 4 hours. After that, the coolant will either evaporate or migrate, and will lose conductivity. So we fix it properly once we're clear of the field. Savrak looked at the relay housing for a long moment. Their compound eyes, which I could not read, which I had given up trying to read in any detail, moved across the jerry-rigged junction with its improvised liquid bridge. In 14 years of service on this vessel, they said, I have not seen a solution of this type. 14 years of the problems being solvable the right way, I said. Lucky ship. Savrak made the sound I didn't have cataloged yet, the one from the floor of Engineering Bay 3. I was adding data points to it. It was starting to resolve into something I might eventually have a word for. We went to the navigation bay. We flew the ship through the debris field. My terminal flagged a cluster event at hour 2. I pushed manual override, and the correction took 340 milliseconds, 160 more than a Velhari would have needed, but 660 less than the rock needed to reach us. Math, as always, coming down on the side of continued existence. At hour 4 and 6 minutes, we cleared the debris field boundary. At hour 4 and 12 minutes, I started the proper repair. I documented every step. Failure of secondary coupling. Noted. Modified chemical cure time. Noted. Coolant bridge conductivity profile. Noted. Because that's what you do. Failure is data. All of it goes in the log. Someone, somewhere, is going to need this information someday, and that someone might be me. And the situation might be worse. I filed the log and went to find out if Velhari ships had anything resembling coffee. The answer, it turned out, was a pressurized fungal extract that tasted like someone had steeped a gym bag in hot water and then felt bad about it. I drank 2 cups. It was that kind of day. 18 hours after the micrometeorite, I found out that it had also hit something else. The resonance of a chord runs on a cascade drive, not a human term. That's my translation of the Velhari phrase, which means roughly a thing that falls forward in a very specific way. The drive works by creating a controlled resonance cascade in a supercooled reaction chamber. The resonance propagates along a shaped field, and the field interaction with local spacetime is what moves the ship. It's elegant and complicated, and I had spent approximately 40 hours of my posting reading about it because I could not help myself, and also because it's beautiful physics. The reaction chamber has to be kept at 4.2 Kelvin, colder than space itself, which is around 2.7 Kelvin. But the chamber needs active cooling to maintain that specific temperature because the resonance process itself generates thermal noise. So there's a cryogenic cooling system running constantly. The cooling system has 3 independent loops, redundant, because Velhari engineering doesn't mess around with redundancy, and each loop carries a different refrigerant compound. The micrometeorite had grazed Loop 2's primary feed line on its way through the ship. Not severed it. Grazed it. Enough to weaken the feed wall. Without breaching it immediately, the weakened section had been under pressure for 18 hours, slowly developing a microfracture that the ship's passive monitoring hadn't flagged because the fracture was below the detection threshold. Growing the whole time. I know this because at 2110 ship time, the microfracture became a macrofracture. The second cryogenic loop partially failed, and the reaction chamber temperature began rising from 4.2 Kelvin. Target temperature, 4.2 K. Acceptable operating range, 4 to 4.5 K. Maximum safe temperature before resonance cascade becomes uncontrolled resonance cascade, which sounds exciting and is in fact an extinction event for everything within about 60 kilometers. 5.1 K. Current temperature at failure, 4.2 K. Rate of temperature rise with loop 2 at 30%. 0.0. 4 Kelvin per minute. Time to maximum safe temperature, 5.1 minus 4.2, divided by 0.04 equals 22.5 minutes. But, as temperature rises, thermal noise in the chamber increases, which accelerates the rise. Not a linear function, more like exponential after 4.7 K. Revised estimate to critical threshold, 17 minutes. Possibly 15. I was already moving when Savrak's voice came through the ship intercom, calm and precise, explaining the situation to the rest of the crew in Velhari, which my caller translated with a 2-second lag. I didn't wait for the translation. I already knew. 17 minutes. 3 things I needed to do, and each one took time I didn't have. First, repair or isolate Loop 2. If I could stop the refrigerant loss, Loop 1 and 3 might compensate. Loop 2 repair. The correct procedure required a cryogenic seal kit, of which we had exactly one, which was in engineering supply on Deck 4. Transit time, 4 minutes. Seal application at 4.2 K surface temperature. Tricky, because my hands would stop working properly below about 10 Celsius and the repair zone was going to be considerably colder than that through the insulation. Estimated repair time, 8 minutes if everything went perfectly, 12 if it didn't. Second, reduce drive output to decrease the thermal load on the chamber. Less resonance, less thermal noise, slower temperature rise. But reducing drive output in the middle of an interstellar transit means you're no longer at the calculated emergence point for your destination. You drift. In Velhari navigation, Drift is calculated and compensated precisely. It's not catastrophic, but it requires a full recalculation of the emergence trajectory, which takes time on the navigation system, and the navigation system was currently running on my improvised coolant bridge, which was now, per my earlier estimate, in its final functional hour. Third, the emergency drive shutdown. If nothing else worked, you could do a full emergency shutdown of the cascade drive, which would stop the thermal rise completely. It would also strand the ship in interstellar space with no drive capability, while the system cooled and was restarted. A process that takes 11 hours. 11 hours of sitting in the dark between stars, running on backup power. Not fatal. Just the worst option that wasn't dying. I did the triage math in my head while running for the cryogenic seal kit. Option 1 repair. 4 minutes transit plus 8 minus 12 minutes repair equals 12 minus 16 minutes. Temperature at 16 minutes. Approximately 4.84 K. Inside the exponential acceleration zone. If repair takes 12 plus minutes, we're in critical range during the final steps. Risk, high. Option to reduce drive output. Buys time, but breaks navigation system, which is already fragile. Risk, compounding. Option 3 shutdown. Guaranteed survival, 11 hours stranded. The math says this is the right answer. The math is probably right. I really don't want to be stranded for 11 hours. I grabbed the seal kit from engineering supply and started back for the cryogenic loop at a dead run. Savrak met me at the junction between deck 4 and 5. All 4 limbs in motion, carrying a secondary kit, different equipment. Their version. The components I didn't have names for yet. The correct procedure, Savrak said, running alongside me in that 4-limbed lope that covers ground like nothing I'd ever seen, requires a full thermal equilibration period before. I know. My fingers were already getting numb, and I wasn't near the repair site yet. That was going to be a problem. What's in that kit? Thermal insulating compound. For pre-application surface preparation, it would not normally be used in this sequence. If you apply it to my hands before I work the seal, I said, breathing harder than I wanted to admit. Does it protect human tissue at cryogenic surface temperatures? The pause was shorter this time. Savrak was learning the rhythm of my questions, that they were usually load-bearing, that there was a calculation sitting underneath them. It was not designed for biological application. That wasn't the question. At the temperatures involved, it would provide approximately 4 minutes of protective insulation for the application site. That's enough. It wasn't quite enough, but it was enough to work with. Apply it when we get there. We got there. Savrak applied the thermal compound to my hands, a weird, cold then warm sensation, like plunging your hands into very thick, rapidly setting gel. The sensation in my fingers didn't go away, but it became manageable instead of immediately disabling. I started the repair, cryogenic seal application. You clean the fracture zone, you apply the initiator, you press the seal membrane into contact, you apply pressure for the cure time. Simple in concept, complicated by the fact that the fracture zone was at roughly 15 Kelvin through the insulation. My improvised hand protection was doing its best, but wasn't rated for this, and the temperature gauge on my collar display was at 4.41 K and climbing. 4.41, 4.43. The seal initiator wasn't curing. Too cold not because of ambient temperature, but because the fracture surface itself was pulling heat away from the reaction faster than the initiator could generate it. The same thermal dynamics problem I dealt with in Chapter 1, but inverted. Before I'd used a hot surface to accelerate a cure. Now, I had the opposite. I needed to warm the application zone just enough for the initiator to work without warming the cryogenic loop fluid itself. I looked at my options. I had the thermal compound on my hands. Thermal compound that was currently sitting at something close to human body temperature, 37 Celsius, because it had been applied to my hands, which were warm. and which were in contact with the fracture zone. Savrak, I said. Apply more compound directly to the fracture zone. Not on me, on the surface. A thin layer. That will contaminate. It's thermally inert, and the seal membrane will go over it. It'll raise the local surface temperature just enough for the initiator. 30 seconds. 4.51 K. The exponential zone was approaching like a deadline I could see on a calendar, and really didn't want to meet. Savrak applied the compound. I reapplied the initiator. The chemistry on the fracture surface changed. I could feel it through the insulation on my hands. A faint difference in resistance. The texture of a reaction beginning. The seal membrane went down. I applied pressure with everything I had. 4.54, 4.56, 4.57. The seal cured. The fracture closed. Loop 2. Refrigerant loss. Stopped. I held the pressure for the full cure time while watching the temperature gauge. 4.58, 4.59. And then not immediately. Loops don't equilibrate instantly. A pause. The rise slowing. Loop 1 and Loop 3 compensating. Refrigerant circulation redistributing. The chamber beginning to pull heat back out instead of accumulating it. 4.59, 4.59, 4.58, 4.56, 4.53. I let go of the seal and sat down on the floor of the cryogenic corridor, which was approximately -12 degrees Celsius at floor level, because insulation only does so much. And I did not care at all, because the temperature gauge was reading 4.49 K and heading the right direction, and the math had come out on the right side one more time. My hands, when I looked at them, were a spectacular shade of red. The thermal compound had done its job. 4 minutes of protection, and I'd used 3 minutes, 40 of them. I was going to have very impressive-looking hands for a few days, but impressive-looking was a significant improvement over the alternative. The temperature, Savrak said, is returning to nominal. Yeah. I was watching the gauge like it owed me money. 4.44, 4.4, 4.35. Yeah, it is. Savrak stood in the corridor doorway. The subsonic hum from their thorax was doing the thing I still didn't have a word for, the one I'd been collecting data points on all day. But there were more of them now. More instances, more context, and I was starting to think I knew what it was. You calculated, Savrak said, the temperature rise rate, the repair time, the protection duration of the compound, the thermal effect on the initiator, the equilibration curve, all simultaneously. Not simultaneously, sequentially, very fast. I flexed my spectacular red hands carefully. And I got some of it wrong. My first estimate was 17 minutes. Actual time to critical was going to be closer to 14. I had less margin than I thought. You knew this? I knew my estimate had uncertainty. I didn't know which way it was off until I was already in the repair. I looked up at Savrak. That's why you don't stop. You start with the best model you have, and you update it as you get more information. Stopping and waiting for a perfect model is just dying more slowly. The chamber temperature hit 4.21 K, just barely above nominal, 1/100th of a Kelvin above where we'd started 18 hours ago. The math had forgotten the second micrometeorite damage. It had forgotten the Loop 2 fracture growing in the dark for 18 hours while I was busy congratulating myself on the other problems. I made a note in my log. Post-incident, perform full ship structural integrity scan. Micrometeorite damage assessment should not be limited to immediate effect zone. Check everything. The problem you haven't found yet is the one that kills you. I went to perform the full ship scan. The scan took 47 minutes. It found 3 additional stress points in the hull microstructure that needed monitoring. None immediately critical. All logged, flagged, and added to the maintenance queue. I handed the report to Savrak, who read through it with four-limbed stillness. The subsonic hum was very quiet. "You searched," Savrak said, "for problems that did not yet exist. I searched for problems that hadn't announced themselves yet. Big difference. I saved the log file. Today's problems already announced themselves. Loudly. I just wanted to know what was waiting in line." The hum rose slightly. Briefly. I had enough data points now. It was the sound Savrak made when something didn't fit their model of the universe and they were in the process of making room for it anyway. Not confusion. Not alarm. Something closer to the beginning of understanding. I flagged the 3 hull stress points for tomorrow's maintenance window and went to find my bunk. The math had been bad all day, and it had been wrong in at least 2 places, and I had made it work anyway, and my hands looked like I'd lost a fight with a lobster, and I needed 6 hours of horizontal existence before I was useful to anyone. But the log was complete. All the failures were documented. The data was there for whoever needed it next, including me. When the next problem showed up, and there would be a next problem. There always was. I was looking forward to it in the particular way that a person who genuinely cannot stop themselves from solving things looks forward to the next thing that needs solving. I set my alarm for 6 hours and went to sleep.